Hi everyone, welcome to today's lecture. Today I am going to teach you the fundamentals of spectroscopy, that is instrumentation part. This instrument which I am going to show you a demo here, this demo applicable to all spectroscopic instruments, provided you just have to remember what are the basic components of an instrumentation of basic spectroscopy. So let us begin to my lecture. This is Dushyant Reddy. We are here to explain you the instrumentation part of spectroscopy. If you like the lectures, subscribe and share among your friends. Now for your any spectroscopy, say UV, visible, IR, NMR, mass, HPLC, any part of spectroscopic technique, the first most important part of your spectroscopy is your source of your light. So generally the light source are divided into two types, that is a line source and a continuous source. So what do you mean by continuous source is that it's the light keep on propagating into the medium of your solution, thereby the changes you observed in the solution you record as a spectrum on your screen. So this continuous sources have some drawbacks because of lot of noise appear in your data, whereas line sources, what do you mean by line sources? These sources are very specific to certain characteristics such as wavelength, absorbance, or whatever it is. They are characteristics of the analyte of our interest. So the line sources are preferred than the continuous sources in spectroscopy. So what are the characteristics of light? All these fundamentals I have already explained you on all the spectroscopic techniques. In generally, the light is polychromatic in nature, which contains both particle nature as well as wave nature. It contains the magnetic properties as well as electric properties. And this polychromatic nature, the electromagnetic properties are in right angles to each other. That's what the electric vector and the magnetic vector are right perpendicular to each other. They propagate. Now, in any spectroscopic techniques, what happens is the polychromatic light, the light which is in multiple direction, falls onto a collimator. What do you mean by collimator? Collimator is the thing which focus your light onto certain thing. That is the part of your collimator. Now after falling onto the collimator, the light from the collimator enters into the entrance slit. This is your entrance slit. After falling into the entrance slit, the light with complete focus, they fall onto either onto the prisms or onto the diffraction gratings. So why we are using prism or diffraction gratings here is the conversion of polychromatic light into a monochromatic light, or the conversion of non-polarized light to a polarized light. So this is a fundamental information. So if you see whatever I have shown here, in the equidistance of black lines, this show you a polygraphic plate onto which you have a different number of spacing of gratings, or you can have a simple prism monochromators. So now what happens? These polychromatic light, once they fall onto the collimator focus the light through the entrance slit. It falls onto the monochromators or diffraction gratings. Either it is a prism or a diffraction gratings. These two converts the polychromatic light into a monochromatic light. Now you would get a very big question, how this will convert. This contains a lot of physics. What happens is, once each light particles falls onto this equidistance of gratings, some amount of light refracts or diffracts or reinforces, or some phase difference. So now there is a multiple calculations, out of which only the single plane polarized light will come out. That plane polarized light which is come out, that will fall onto the exit slit. Now this is your entrance slit, this is your exit slit. Now the light from the exit slit will go here and it will go on to this sample as well as reference solutions. Now this sample and reference, these will have the compartment into which they are filled. So it should be of either quartz or glass. So if you are using sample UV experiments your what do you say, the cuvette which you are using are generally of quartz, because of glass absorbs your UV radiation. Whereas if you are using any other fluorescence or any colorimetric methods, you can use simple glass as your cuvette. So this is a fundamental information. Now whatever the monochromatic light falls onto the sample as well as reference cell. So many of you have a very difference between what is a polychromatic light and a monochromatic light. Suppose if you have only one compartment, one cellular compartment in your instrument, where you keep on putting your sample as well as first you put your blank, that means in which your component is dissolved. After that you put your sample solution and you analyze the difference between the blank and the difference between the sample. You read as a spectrum. This is a fundamental information. However, the double beam spectroscopic techniques are also, and nowadays it is very useful, in which what happens, the monochromatic light is split into two parts, that is a beam splitter is placed. Here you have a beam splitter. This beam splitter splits the light into equal parts, so half of them goes onto the sample and the half of them goes onto the reference. So now the difference between the that is your blank as well as your sample, you read the spectrum onto your data. So this is the fundamental information you get from any chromatographic techniques. So now come to fluorescence instrument. So here again the source of light is helium or helium discharge lamp or mercury vapor lamp. It comes and falls onto a collimator. What collimators do? Again the source is polychromatic in nature. The collimator focus the light onto through the entrance rate onto the prism or diffraction grating. What the diffraction grating do? They filter the polychromatic light and make it into a monochromatic light. Now the monochromatic light, here in the fluorescence you have two wavelengths of characteristics of your particles. One is your excitation wavelength and another one is your emission wavelength. Now in this case, the excitation wavelength should be selected before the part of the sample and the emission wavelength should be selected after the part of the sample. So this filter which is placed, that is your filter which is placed just before the sample, will select the excitation part of your sample of interest. Now after getting the excitation part, now once the sample will releases the light which is falling onto the screen should be passed through one more filter. This is called as emission filter. So however, this spectroscopic technique, if you clearly observe, there is some big error in this instrumentation part. What is the error is, if it is for fluorescence, this instrument cannot work. Suppose if it is for UV, it is a perfect instrument, because the source of light as well as your detector are in the same line. So this means it is a simple UV where you observe absorbance and transmittance are observed. Suppose if you are using for the fluorescence instrument, the same detector part should be at 90 degrees from the source. That means you have the light source here, you should have the detector part towards here, not towards here, because what happens is the emission and the transmittance come onto the same part, you will get a lot of noise in the signal. That's why you always measure the emission part at 90 degrees from the source of light. This is the fundamental information. Similar to your turbitometric and nephlometric analysis. In the turbitometry, you measure the light at 180 degrees towards the source, whereas in the nephlometric part, you measure towards the 90 degrees to the parts. So these are the fundamental components of your instrumentation part. So every instrument contains all these in one or another fashion. So what are the components? Let me tell you one more time. The first component is your source of light. So how many types of source of lights are there? Two types. One is line source, another one is continuous source. So again, this light is polychromatic in nature. It will fall onto, what do you say? Here again I am showing you. This is your focuser, that is collimator, which focus the polychromatic light into the entrance slit. Through the entrance slit, this polychromatic light falls onto prism or gratings. After it falling onto the prism or grating, due to some internal refraction or diffraction or with the phase difference, only the monochromatic light comes out. Whatever the monochromatic light coming out through fall onto the exit slit, this after coming into the exit slit, it goes on to beam splitter, which split the monochromatic light into two compartments. One goes on to the sample, another goes on to the blank, another goes on to the sample. Now the difference between blank and sample you observe onto the detector. So this is a fundamental information in any spectroscopy technique. Suppose if you come for fluorescence spectroscopy, you have one more additional part. One is your excitation filter, and another one is your emission filter. So this is the fundamental. Now if you take for UV, the same instrument, Nephlometry, same instrument, Turbitometry, same instrument, fluorescence, same, calorimetry, same. So the every part is same here. The only thing is sometimes you may change your source, sometimes some additional components come and add on to your instrumentation part. Apart from these, the complete spectroscopy is same. So this is completes today's lecture. Hope you understand, and like my channel and subscribe and share among your friends. Thank you.